So this is section 10.8 on polar graphing, and we're going to look at the different names for polar graphs, and eventually you're going to have these names and their graphs memorized. Not the equations, but just be able to identify the name with the picture. So these first four, we have several what are called limacons, and there's different options with those. The first is a limacon with an inner loop, so you can see that inner circle inside the graph. The next one is a cardioid, and the reason called a cardioid is because it looks like a heart. The third picture is a dimpled limacon, so you can see that it kind of dips in on the left-hand side, but doesn't come to a real point. And then the last limacon is a convex limacon. You can see it's kind of flat on the left-hand side. It doesn't dip in or protrude out on the other side. It's just real flat on one side. Okay, the next four on the top are all rose curves with different numbers of petals. And we'll start to see the relationship with the number of petals and some numbers inside the equation. But if it looks like a flower, we're going to call it a rose curve. Okay, and then the first two on the bottom row are circles. Hopefully you should be able to identify a circle. And the last two are called lemniscate. And they kind of look like a figure 8 or an infinity symbol. Okay, so what we're going to do now is we're going to go through the settings on your graphing calculator, how to set up to graph and polar, and that's all we're doing in this lesson is graphing. So I'm going to show you how to put them in the calculator, change all your settings, and then you should be able to plug those in and graph them pretty easily. So the first thing we're going to do is go to mode on our calculator, and most of the other settings should be the same, but we want to make sure that we're in degree mode and polar. Okay, so then if you hit y equals, you're going to notice now it's r equals. A couple weeks ago when we tried parametric equations and we changed it to parametric mode, we had x1, y1 together. So that was for parametric equations. When we switch to polar, our equations need to be r equals. So we're just going to type in r equals 5 and leave it there for now. We're going to go to the window and change your settings in your window. We want to go from negative 360 to positive 360 with a theta step of 15. So we want it to graph every 15 degrees. Then we're going to go to zoom, and this time I want to do number 5, zoom square, because you're going to notice some of these are going to look a little wapajawed, they're going to look a little squished sometimes. So if it's at zoom square, it's going to square everything up and look the correct way. And then last, we're going to go to our table setup, and we want our table to start at 0, but the change in table to be 15, so that when I look in the table in a second, I'm not seeing every degree listed one at a time. It's going to go from 0, 15, 30, etc. Okay, so now if you hit graph, you're going to see that r equals 5 is a circle with a radius of 5. Before, when we tried to graph circles when we were in rectangular mode, you'd have to get the y by itself, and so you'd wind up having a square root of something in one equation and a negative square root of something else in another equation, and the circles would never meet. The halves of the circles would never touch, but in polar mode they will. Okay, so then we can also go to our table and we can see the values. We've got our angle values in the first row and then our r values in the second. Okay, so let's look at some examples and see how these graph. So the first one, number 1 is r equals 5, which we just put in our calculator. So when you're graphing this on a polar graph, r equals 5 means that every angle, the radius is 5. So you can put points out there on the 5th circle at every point or at every angle, and that would give you your circle. Okay, number 2, I've got r equals 4 times 1 plus sine theta. So I've drawn a table here so that when you put this in the calculator and go to your table, you can write down some of these key angles and then connect the dots with your picture. I'm going to go through these kind of fast and not plot every single point, but throw the points up there and then look at what the graph is. So when you type 4 times 1 plus sine theta in your calculator and you go to the table or go to graph, this is what you're going to get. So I just picked some angles from 0 to 360. It doesn't have to be a whole bunch of angles, but we want to try to get all the way around the circle at some point. If I just graph in quadrant 1, we're not going to get a good picture of our polar graph. Okay, so when this is finished graphing or you've connected all of your dots, you're going to see that this is the graph of a cardioid. Notice that it comes to a point somewhere on the graph. They dip in and comes to a point. That's what makes it a cardioid. Okay, number 3 is r equals 3 minus 4 cosine theta. So again, type this into y equals and go to your table and get the values. These are the numbers that I picked. Some numbers are going to be easier than others. Sometimes you're going to look at these angles and you're going to have really weird decimals. So I try to pick the ones that are whole numbers, but sometimes it's inevitable you have to pick something else. So this graph is a limacon with an inner loop. It kind of looks like a cardioid, but it does have that loop on the inside. So that makes it a limacon with an inner loop. Okay, number 4 is 2 secant theta. So obviously we don't have a secant button on our calculator, so you're going to have to do 2 divided by cosine theta for secant. So 2 divided by cosine theta, and when I go to my table, this is what I get. So this time I didn't pick as many numbers because I noticed some interesting things happening here. When I plot these points, they wind up being in a vertical line, straight up and down. So it's very interesting how some of these you start plotting points and they make these very interesting shapes, familiar shapes. So this is the equation of a line in polar form. Okay, number 5 is r squared equals 9 cosine 2 theta. Now obviously when you go to y equals, there's not r squared, it's r equals. So we would need to take the square root of the right hand side. So make sure you type r equals the square root of 9 cosine 2 theta. So when I get my table, I have some weird things happening here. And I notice that when I start to connect the points, it makes this little figure 8 shape, which is a lemniscate, or it kind of looks like an infinity sign. Again, if I pick some smaller angles, you're going to pick, or some angles that are closer together, you're going to see those decimals in there. So when I look at this table, it doesn't look like a whole lot of information. Then looking at the graph, you're like, oh, okay, that makes sense.